All right, so thinking in terms of atoms and molecules, if you have 2 moles of sodium and 1 mole of aluminum chloride, so going back a question, which is the limiting reactant? And just a reminder, 1 mole is just equal to 6.022 times 10 to the 23rd of just anything. Again, it could be bowling balls, unicorns, hamsters, it doesn't matter. A lot of times when we talk about this, we could have atoms of sodium or molecules of aluminum chloride. So again, often you don't really need to understand this in terms of atoms, but I want to bring you back to those roots. So if what I'm saying is that I need 3 sodiums to react with every 1 aluminum chloride, we need to compare those numbers of atoms or those numbers of molecules. So we can solve for that really quickly. For every 1 mole of sodium or 1 mole of aluminum chloride, doesn't matter, is the same as 6.02 times 10 to the 23rd atoms of sodium, or is the same as 6.02, sorry I didn't leave enough room there, times 10 to the 23rd molecules of aluminum chloride. Either one is the same. So if we go through and plug these into a calculator, we find that we had, by having 2 moles of sodium, we had 1.20, I'm just going to ignore sig figs for now, 1.20 times 10 to the 24th atoms of sodium. Down here, we just had 6.02 times 10 to the 23rd molecules of aluminum chloride. And so these are all going to be intermingling, they're going to be finding each other and changing up the bonding and producing sodium chloride and aluminum. In this case, we have twice as many atoms of sodium as we did aluminum chloride, but according to a reaction, we actually need 3 sodiums for every 1 aluminum chloride. So looking at it in terms of atoms, we can actually know that sodium is going to be our limiter. We don't have a big enough ratio. We only have twice as many. We need 3 times as many. So just kind of going back to the roots and understanding this in terms of atoms and molecules. All right, from this point on in the slides, if you understand this, you do not need to watch the entire video. This is just meant to help you. So I think the next 5 or 6 slides are all practice problems. I'm going to go through some. If you want to watch them, great. If you understand this, you're more than welcome to just work on your homework, which is assignment 5.3, limiting reactants. So let's try another one. What is the limiting reactant if you have 0.41 moles of hydrochloric acid and 0.23 moles of zinc? So if we go through and start this one off, I'm just going to pick either one. Let's say I wanted to pick, I have 0.23 moles of zinc. Again, you can start with either one. That's what I have, and I'm just going to solve for what do I need. Well, for every 1 mole of zinc, I need 2 moles of hydrochloric acid. So 1 mole of zinc, moles of zinc are going to cancel out per 2 moles of hydrochloric acid, and I find that I would need 0.46 moles of hydrochloric acid. And in this case, if we go back to the problem, it says we have 0.41, but we would need 0.46. So in this case, hydrochloric acid is going to be our limiting, and we have excess zinc. Again, you can double check your work by taking your 0.41 moles of hydrochloric acid and instead converting that into how much zinc you would need. So 2 moles of HCl per 1 mole of zinc. Moles of hydrochloric acid are going to cancel out, and you're going to find that in order to use all 0.41 moles of your hydrochloric acid, you would only need 0.20 moles of zinc. And you look back at the question, well, you have 0.20 moles of zinc. So you can always double check yourself, and therefore we know that zinc is our excess, hydrochloric acid is our limiting. Looking at this question now, you'll notice that this is done a little bit more in a real world sense because again, we can't measure moles. So that's why we use atoms, or I should say mass, instead, because we can actually measure that. So here's a different question. Now determine the limiting reactant if you have 16.2 grams of zinc and 23.5 grams of hydrochloric acid. Again, you can start with either one. I'm just going to start with 16.2 grams of zinc. But now, and this is going back to the poster that I have hanging up, we need to convert from grams of A to moles of A. And A in this case, since we're starting with zinc is going to be our A, hydrochloric acid is our B. So I'm going to have to look at my periodic table, and I actually need to grab one. Looking at my periodic table, I can see that zinc has a molar mass of 63.57 grams, and that's always per 1 mole. Grams of zinc are going to cancel out, and now I'm in terms of moles of zinc. Well, that's not what I need. I need to work my way over to, and next I'm going to go to moles of B, and then I'm going to work my way over to grams of B. So to continue on, I have 1 mole of zinc for every 2 moles of hydrochloric acid. Moles of zinc are going to cancel out, and now I'm at this step where I'm converting my moles of B to grams of B. And to do that, I'm going to take that 1.01 grams for hydrogen plus the 35.45 grams for chlorine, and we would find that 1 mole of hydrochloric acid is equal to 36.46 grams. Moles of hydrochloric acid are going to cancel out, and then you plug this into a calculator, and you find that you would need, again, that have versus need, you would need 18.6 grams of hydrochloric acid. So going back to our question, we started with, we actually have 23.5, we only need 18.6 in order to use up 16.2 grams of zinc. So therefore we can confidently label that this hydrochloric acid is going to be our excess because we have extra of it, and this zinc is going to be our limiting because it's going to run out. And sorry, I should have clarified on here, this is continuing on from the previous slide. So in our previous slide, we determined that zinc was our limiting reactant. And if I remember correctly, it said that we had 16.2 grams of zinc. Since that's our limiter, that's what's going to hold us back from making more of this zinc chloride product. Just like, in the previous question, when we didn't have enough tires, it held us back from making more bikes. It's the exact same thing. But now, if we wanted to just solve for how many grams of zinc chloride do you produce, it's literally the exact same process. You still just follow those grams of A, which in this case, zinc is going to be our A again, converting to moles of A, converting to moles of B. And in this case, zinc chloride is going to be our B, and then we just convert that to grams of B. Because again, just like in the other questions where if I take zinc and I solve for hydrochloric acid, it's telling me to use up every last bit of zinc, that's telling me how much hydrochloric acid I would need. Now what it's doing when you solve for a product is if I used up every last bit of that zinc, it's telling me what is the maximum amount of zinc chloride that I could produce. So that's what we're going to go through and solve for. So we're going to start with our 16.2 grams of zinc. We go back to our periodic table where we see that zinc has a mass of 65.37 grams, and that's always per 1 mole. And right now we are done with that step. We've converted from grams of A to moles of A. Then we look at our ratio. In this case, it is 1 mole of zinc for every 1 mole of zinc chloride produced. So it's just a 1-to-1 ratio. Moles of zinc are going to cancel out, and I guess the grams of zinc cancel out as well. And we're already done with this step. Last step is just converting to grams of B. To do this, we're going to add the mass of 1 zinc. So 65.37 grams plus the mass of 2 chlorines. So 35.45 times 2. Plug all this into a calculator. You find that zinc chloride has a molar mass of 136.27 grams. And again, that's always per 1 mole. I should say zinc chloride, sorry. Mole of zinc chloride is going to cancel out more mole of zinc chloride. And when you plug this in, you find that you'd be able to produce 33.8 grams of zinc chloride. So no matter what, and you can even do the reverse. If you want to say you're doing a lab and you're like, you know what, I really need to produce zinc chloride. You could ask yourself, how much hydrochloric acid do I need? How much zinc do I need? So you can always just do these steps, grams of A to grams of B. It doesn't matter if you're going from product to reactant or reactant to product or reactant to reactant. It's the exact same steps. But what this problem solved for is if we used up all 16.2 grams of zinc, this is the maximum amount of zinc chloride that could be produced. Again, once you understand what you're doing, you do not need to keep watching the video, but I want to keep working through this for those of you that need extra help. I know it's a lot, I know it's challenging, so let's keep working through it. So determine the limiting reagent in this scenario. If you have 4.8 moles of sodium chloride or 2.3 moles of lead 2 nitrate. So what I'm going to do, again, I just usually pick whichever one is first. I'm going to take my 4.8 moles of NaCl, and I am just going to convert that to my other reactant. So I'm just going to convert that over to this lead 2 nitrate. So I need 2 moles of NaCl for every 1 mole of lead 2 nitrate. So I can take my moles of NaCl, cancel those out, and if we solve for this, we find that we would only need 2.4 moles of lead nitrate in order to use up all of our 4.8. So in this case, I know this one's a little bit closer, so it's going to be harder to reason, but to use up every last bit of our 4.8 moles of NaCl, we would need 2.4 moles of lead 2 nitrate. In this case, we only have 2.3 moles of lead nitrate, so what that's telling me is that our lead nitrate is actually our limiting, and our sodium chloride we would have excess. And now to solve for this question, how many grams of lead chloride would you be able to produce? Since it is our lead 2 nitrate that is our limiting, that's what we have to start with because that's what's going to hold us back from producing more. So we're going to start with that 2.4 moles, I'm sorry, not 2.4, we only have 2.3. We're going to start with that 2.3 moles of lead 2 nitrate. And in this case, the only conversions we have to do, we're starting with our moles of A. So we're kind of getting rid of that, we're skipping that grams of A step. We're going to convert our moles of A to moles of B, our moles of B to grams of B. So right away we're going to jump into this mole of A to mole of B conversion. And going back to our equation, we have A is our lead nitrate, and B in this case is actually going to be our lead 2 chloride, and that is just a 1-to-1 ratio. So I have 1 mole of lead 2 nitrate for every 1 mole of lead 2 chloride. Moles of PbNO3, 2, moles of PbNO3, 2 cancel out. And then our last step is to convert 2 grams of B. And in this case, if you add together 1 lead plus 2 chlorines, you find that that 1 mole of PbCl2 has a mass of 278.09 grams. And after plugging this in, you find, and if we follow sig figs, you would produce 640 grams of lead chloride. All right, just more chemistry fun here. So in this case, I'm going to take my 6.2 grams of phosphorus. I'm going to convert that over to my I'm just going to convert that to Br2. So we can see that phosphorus has a molar mass of 30.97 grams, and that's per 1 mole of phosphorus. Grams of phosphorus are going to cancel out. Our ratio from phosphorus to bromine is 3:2. So therefore we have 2 moles of phosphorus per 3 moles of Br2. Moles of phosphorus are going to cancel out. And then the last thing is we need to convert to grams. So 1 mole of Br2, 1 bromine is 79.91. So multiply it by 2, and we find that bromine has a molar mass of 159.82 grams. Moles of bromine are going to cancel out, and therefore we find that we would end up needing to use up all 6.2 grams of phosphorus. We would need 48 grams of bromine 2. So in this case, our bromine 2 is actually going to be very, very, very limiting. We're not even close to having enough Br2. So that's going to be very limiting, and our phosphorus is going to be very much in excess. And now the question is asking us to continue on. How many grams of PbR3 is produced? So we're going to start with what we have here of bromine 2. So 4.3 grams of bromine 2, and we're going to convert that over to PbR2. So we can basically just pull our information from up here. We already know how to convert grams to moles for bromine 2. That is, there are 159.82 grams of bromine 2 per 1 mole. Bromine 2s are going to cancel out. And now our ratio for this, 3 bromine 2s for every 2 PbR3s, or phosphorus tribromides. And so we're going to put our, 3 moles of Br2 per 2 moles of PbR3. And then we need to find the molar mass of PbR3. Which has a mass of 270.70 grams of PbR3. When you plug all this into your calculator, you would find that you would only be able to produce 4.9 grams of PbR3.